Hello there viewers, this is Engineer Saman, and today we'll discuss about PLC programming and how to control our industrial control trainer using PLC LEDSIM software on the basis of ladder logic. So this industrial control trainer is used to simply assemble the two pieces automatically, uh, having three stations. The first station is classification, second is assembly where part is assembled, and the last stage is inspection where the material is checked and sorting is done over here. So let's start with the software, and we will design a PLC program which can automatically run this machine and can easily automate the sensors and actuators. So this is LEDSIM software, which is also called ladder simulation software. This is same as LogicPro software. It contains over here input stations, outputs. Inputs are those switches which are used to, such as the simple switches used in our homes, and to switch on lights and fans and other etc. And here output is shown as LED bulbs. So you are not actually having over here microphones or sensors or any driven motor. So that's why we are simply using these input switches to show these LEDs. By showing these LEDs, we can simply assign them as a motor or other things. So let's start with the simulation to control the industrial control trainer. As you can see that the first step is to drive this motor continuously so that these two conveyor belts can run throughout the process. So the first step is to drive the motor continuously. So I would like to start with normally open contact, drag over here, and let's assign input 0 to this open switch. So over here this input 0 is switched with this program. When I click on simply this input 0, I am switching on this fan or motor or whatever, and by clicking off I'm just simply switching off this conveyor belt. And this is our output station, which is simply latched with this output. So output 0. Okay, now let's run this software so we can easily understand running simulation. Now you can see that when I click on this input 0, you can see that electricity is passed through this series, and our output, our conveyor belt motor is a start. So by doing series of different actions, we can simply create our simulation. So let's add another rung. The first step is done. Second step, now you can see that in this these parts are placed randomly on this conveyor belt, and here we have a classification section. After motor is driven and these parts came into this classification section, here we have three components. The first one is this infrared sensor, second one is this metal detector, and third one is placed on the right side of this section, which is called solenoid valve, or also called actuator. So when plastic material is detected by infrared sensor, so the only detection of infrared will send the command to actuator, and that solenoid valve will push this plastic material over here. So we have to design for that another open switch, and input 1 now this time, because we have already provided input 0 and assigned it to the conveyor belt motor. So input 1 be assigned to this infrared sensor. Okay, and this output over here to show it with our output 1. Okay, you can also add different instructions for yourself. For example, rung 1 is for conveyor belt and rung 2 is for you can see infrared sensor or plastic detection. But I'm not going to use this because it will make a little bit confusing for you when I simply scroll these rungs. So let's leave it over here. Rung 2 is for infrared sensor plastic detection. Okay, so here we have already used rung 1. Insert another rung. Now This infrared sensor, you can assume that this plastic sensor, this plastic material came under this section. This infrared sensor is detecting this plastic material, and solenoid valve is pushing over here. Running simulation, and you can see that our conveyor belt is on, system is on. For example, when I click this push button, it means that infrared sensor is detecting plastic material. Infrared sensor detected plastic material, and this output 1, you can see that output 1 is on, which means that solenoid valve is pushing. And when the material is pushed away, it would not detect any signal because the material is not there. So that's why this solenoid valve will become auto switch off. Material came, simple click, detecting signal, and solenoid valve is open at output 1. Okay, so this is for plastic detection. Now the system is designed in such a way that metal detector and infrared sensor are positioned at the same place. When metal came at this position, so infrared sensor is able to detect metal too, and metallic sensor is also detecting that. So when these both sensors detect that object, that metal object, so then they would send command to this solenoid valve to become shut off, means that they would let this metallic material to bypass from that position, and solenoid valve will not work in that case. So let's start for that. Stopping simulation. Another output 0 is for conveyor belt. Input 1 is for conveyor belt input, 1 is for infrared, so we will be using input 2. And now this is for metal sensor, metal detector. We have to use one more for this infrared sensor, because metal sensor is detected by this infrared as well as metal sensor. So infrared is input 1, we are using input 1. Okay, I'm just shifting it over here so that we can it is not confusing us. This infrared sensor is detecting plastic material, so it would push that solenoid valve, and same infrared sensor is detecting metal, but also with the detection of metal detector. So output used over here is output 2. Now let's check the simulation. Conveyor belt is on. Conveyor belt is on over here. Infrared sensor is detecting, and when metal is also, so this one is for conveyor belt, this one is used for plastic material, and this one is used for metal sensor. But now you can see that when metal is sensed by these two sensors, so at the same time they are, solenoid valve is open, so we have to unlatch solenoid valve. So what we are going to do, we will just simply introduce normally close contact over here, and we would provide it output 2. Running simulation. Now you can see running conveyor belt, metal sensor detected, and it would allow to solenoid valve to push it, and when these two signals are working at the same time, means that metal is detected, so it would let that material to stop that pushing, and it will let that material to bypass through that channel. So normally close contact is used where you want your process to reverse, so that's how we are dealing with it. So here we are done with the running of conveyor belts with the classification system. Now you can see that in assembly portion, this metal is moving forward with the help of conveyor belt, and due to this frame design it is auto assembling itself. But you can see that here another sensor is installed which is used to show you the limit of plastic material. For example, your pieces are placed over here randomly, and plastic materials are collected over here in large amounts, so at the end solenoid valve would not be able to push it because the limit is reached. So at this position infrared sensor is installed which is used to tell you that you have reached your limit and stop the conveyor belt so that it can stop sending more plastic material. So let's deal with this another infrared sensor which is also used as a limit sensor. So adding another rung, we have already used input 0, 1 and 2. Now we will assign it input 3, and with the output same output 3. Now we want this station to work in such a way that when this rung this infrared sensor sends any kind of sensitivity. For example, if it sends the material continuously, so it will send this information to this main rung, this main conveyor belt, to stop the material because the plastic materials are collected in enough amount. So we are using normally closed switch, and we will latch it with output 3. Okay, running simulation. Input 1 conveyor belt on, input 1 plastic material detected. When both are detected, so it will stop solenoid valve. And for example, input 3 is the position where plastic material are collected in big amount, which is second infrared. So let's start it, and you can see that it had already automatically stopped that main conveyor belt, which means that now this conveyor belt is not sending any more pieces because the whole system is stopped. So now we have to use a timer over here because at the same time we would let the material to run. So we want it such as let's say we want the process to stop for 1 to 2 minutes, so we can use a timer over here. Stopping simulation, add another rung. Normally open switch. This output 3 is connected with it. Output 3, when sensor detect, it would send the information to this output. So I am connecting this output information with this switch. So when this outputs at the output infrared sensor sends something, it would send information to this, and at the same time our timer becomes on. Timer option is this. I've selected this T1, and it wants you to at how much seconds you want your process to run, to stop. So normally we will do for 1, 2 or 3 minutes, in minutes or maybe for hours, to stop our process, but to demonstrate you in this video I'm just using 5 seconds. Okay, so what is done over here, when the second infrared sensor collected too many materials, it would sense it and send the information to this timer, and the timer will start for 5 seconds, but we have to use that timer information again to do something for us. So another switch is installed. Now you can see that we have to connect complete timing. So T1, T and D means done. So when the timer is done with counting for 5 seconds, we will then receive a message, and at the output we would assign it output 4 because output 1, 2 and 3 are already assigned. So output 4 is over here. So what does it mean that timer will send the information to this output 4 by counting it till 5 seconds? And let's use this output 4 over here. We have to add a branch. Now we have to add a normally open switch and connect it with output 4. Now you can see that why we have done that situation. For example, infrared sensor is detecting output information. So this is used as a continuous ongoing. When this infrared sensor detect limit reach, it would open this normally closed switch and the system is running. But when after timing completes for 5 seconds, we will receive our information at the output 4. So that output 4 will send this information over here and it will complete the signal, and again we can run our system. So let's start with the simulation. Okay, uh, let's start our conveyor belt started successfully. Our process is running. Let's detect with plastic material detected and solenoid valve is pushing. This is used as a solenoid valve. Okay, output 1 is solenoid valve for actuator. When input 1 and input 2 means over here a metal can be detected by these both of these sensors. So when both these sensors detect any metal, it would not send any information to this and the material will bypass to that channel. So detection of both these, it would let the solenoid valve stop and it is showing us information that the material is passed. Now we are using rung 3. When we use rung 3, remember that it would stop the complete process for 5 seconds because we have provided timer 5 seconds, and exactly after 5 seconds it would send information to this switch. If the switch will become closed and our process will start again. So let's click on this input 4. This is, sorry, sensor 2, so it doesn't have to work in that situation. And let's start with input 4. Okay, input 3, this is input because when input 3 sensor detects, so it would stop the mechanism and start after 5 seconds. So this is input 3. Let's do it. You can see that actuator is counting 1 2 3 4 5, and here you can see that our connection is also in contact. So right now we have completed our simulation. Most of it is done. Another portion is assembly, is inspection, where your capacitive sensor is installed, which is used to detect the complete assembly by analyzing the complete cross-sectional area. If the cross-section area is lower than required, then it means that only single pieces from one of these is bypassing, so it would send the information to solenoid valve to hit that material, push that material. And when this capacitive sensor detects more greater cross-sectional area, so it can easily understand that the material is in perfect contact and it would bypass it through solenoid valve. So let's add another rung, uh, normal open switch, input 4. I think input 4 should be used over here. Yes, input 4 is used over here, and solenoid valve is placed over here, which is output 5. Because output 3 is another sensor, output 4 is the another option which will send us timer. So output 5. Okay, let's start the complete simulation again. First close this. Okay, complete simulation. Now we are done with our simulation. Let's start it. Starting the complete process. Conveyor belt is on. Infrared sensor is detecting plastic material and solenoid valve is active. When both of the materials are detected, so solenoid valve is stopped. When when infrared sensor to detect a maximum limit of plastic material collected, so it would send the information in 5 seconds. We start the timer after 5 seconds. Yes, it is on. And after that, our fourth input, this is our fourth, sorry, here by clicking on input 4, or or another solenoid valve will push that material, because that would be imperfect assembly. So input 4 is showing output 5. Yes, exactly, output 5, because input 3 is connected with this output 4. So you can easily see that how we can play with these simple switches to control our simulation. Sorry for the coughing. Thank you so much. I hope you have understood a little bit about, and thank you so much for your patience. This is Engineer Vasawan signing out. Thank you.